again. Here's a question. We have to do one of these proofs that a sequence converges to a number, and this time we've got here's our sequence. We've got to prove that it converges to a half. So we have to go through a sort of reasonably formal routine. It's something like this. The sequence, I apologise for my dreadful writing, the sequence converges to a half if for epsilon greater than 0, however small, there exists n which depends on epsilon such that absolute value of n over 2n plus 1, take away that limit, which is take away the half that we're looking for, is less than epsilon for all n greater than n. Okay, that's our sort of proof statement, and then we have to go through and do it. Basically what we now have to do is find our n, our capital N, and we've solved it. This statement is there's something very similar on your formula sheet. You don't need to necessarily remember that, but you do need to have it clear in your head what's going on. Okay, let's go through it. So what we've got to prove is that absolute value of n 2n plus 1 minus epsilon, which it does if, or it does provided that. I will put these denominators the same to make it look a bit simpler. So we're going to, on the bottom, we're going to get 2 into 2n plus 1. Let's do a bit of fractions here now. I've got to multiply this left-hand part, top and bottom, by 2, so I'm going to get 2n. And the right-hand part, I've got to multiply top and bottom by 2n plus 1. So minus 2n plus 1 must be less than epsilon. And which it is, provided that. And here we get 2n, take away 2n, which is nothing, and then we get negative 1 on the top, divided by, I'll expand this out to 4n plus 2 is less than epsilon. I think I'm going to drop the absolute value signs now. That's true, provided that, because the absolute value of negative 1 is 1, so I get 1 over 4n plus 2 is less than epsilon. I'll invert them, so I now get 4n plus 2 over 1, invert them and change the sign of the inequality, so invert the other side as well, 1 over epsilon. I'll take 2 away from both sides. 4 is bigger than 1 over epsilon minus 2, and I'll divide by 4. Oops, let me just shouldn't have put that line there like that. There we go. Right, back to that. N is bigger than 1 over 4 epsilon minus 2 over 4. And we have it. Therefore, if we let our n be equal to 1 over 4 epsilon minus a half, so we found our n, in other words, so that all our proof will now be satisfied, because all we had to do was find an n such that all that lot was true, and having found that n, it will. So if we let n go, and the sequence n over 2n plus 1 Okay, so that with all these proof things, you basically got to set up your statement in the first place, then go through all the argument, and you have to remember that you have to put these if signs or provided that signs down the left hand side, because what this is actually saying is we've already said at the top what we're trying to prove, and then we go and hopefully prove it. And the logic goes that if we've got n equal to that, then any n bigger than that, this is true, this is true, this is true, this is true, going up. And finally you get to the top, and therefore the sequence converges. So don't forget those ifs or provided that signs down the left hand side. Okay, that's it. I'll stop there.